Hello everyone, this is Shailendra Thaku and I am explaining you time complexity analysis of recursive version of Fibonacci series. After that I will compare the recursive and iterative version of Fibonacci series. As we all know that the Fibonacci series, initially there are two values 0 and 1. After that we will calculating the next value by adding of previous to 1. I have written down the algorithm of Fibonacci series, fib of n. If n is less than equal to 1, return 1, else fib of n minus 1 plus fib of n minus 2. We make assumption that each operation require 1 unit cost time, but in this algorithm it requires 4 unit cost time. For 1 unit cost time for comparison, n is less than equal to 1, and remaining 3 in else condition. 1 unit cost for fib of n minus 1 and 1 unit cost time for fib of n minus 2, 1 and 1 unit time cost for addition. Now the time complexity of this fib of n is t of n. T of n is equal to t of n minus 1 plus t of n minus 2 plus 4, where 4 operations are performed in this algorithm. Now the the t of 0 and t of 1 requires 1 unit cost time, because here in this condition it perform only one operation, comparison. Now the t of n minus 1 is almost equal to t of n minus 2. Here t, in reality t of n minus 1 is uh, greater than the t of n minus 2. So we make the approximation that lower bound. Now t of n equal to 2 of t n minus 2 plus c. Here c is equal to 4. Now above equation reduces 2 of 2t n minus 4 plus c plus c. Now in this manner the next equation is 4t n minus 4 plus 3. Now next equation is 8t n minus 6 plus 7c. Now the next equation is 16t of n minus 8 plus 15c. Now the general form of about this equation is 2 to the power k into t of n minus 2k plus 2 to the power k minus 1 into c. Now I am calculating the value of k. Now n minus 2k equal to 0, that gives the k equal to n by 2. After that we will put the value of k in above equation. 2 to the power n by 2 t of 0 plus 2 to the power n by 2 minus 1 c. Here t of 0 is 1, and after that multiplying c in this bracket. Now the t of n equal to 1 plus c into 2 to the power n by 2 minus c, and this gives the t of n is directly proportional to 2 to the power n by 2, and it gives the lower bound. Now the another approximation is t of n minus 2 is almost equal to t of n minus 1, but in reality t of n minus 2 is always lesser than t of n minus 2. Now we calculate the time complexity of this approximation. T of n equal to 2 of t n minus 1 plus c. Here c is equal to 4. This is calculated as we seen in previous one. Here the next equation reduces the above equation, 4 of t n minus 2 plus 3c. Now the next equation is 8t of n minus 3 plus 7c. Now the general equation of above this equation is 2 to the power k into t of n minus k plus 2 to the power k minus 1 into c. Now I am calculating the value of k. N minus k equal to 0, that gives k equal to n. Now put the value of k in above equation. 2 to the power n t of 0 plus 2 to the power n minus 1 into c. Now after that t of 0 equal to 1, and multiply this c in this bracket. Now the value of t of n is equal to 1 plus c into 2 to the power n minus c. Now the t of n is directly proportional to the 2 to the power n, and it is the upper bound approximation. Now the time complexity of Fibonacci series of recursive version is order of 2 to the power n, and the time complexity of the Fibonacci series of iterative version is order of n. Now when we give the n is equal to 100 in recursion version, it gives the in the the complexity of this algorithm in the form of a to the power b, and if we use the iterative version, it gives the order of n. Iterat now order of n, this type of algorithm is called linear time algorithm, and those who are uses the order of 2 to the power n, this type of algorithm is called the exponential time algorithm. And linear time algorithm is lot better than the exponential time algorithm. Those who are use recursive version, these are called the exponential time algorithm, and it takes lot of time. If we give the n equal to million value, it not give that output in reasonable time, and if we use the iterative version, it gives the in our reasonable times. So this is my algorithm. Thank you for watching this video.